On this video, we're going to be discussing Newton's first law of motion. Okay, so the first thing of any law of motion is to know how to state it off by heart without any reference to a textbook. And the law is as follows. An object will either remain at rest or continues to move at a constant velocity unless acted upon by a net force. Now, although this law does not have a formula, it outlines a very important concept, and that is when the net force is equal to 0. So the first question is, what is the net force? So we define our net force. Okay, so we define our net force as F net. Okay, and it's the sum, so this sign here is just a fancy notation for the sum of forces on the same plane. Okay, so this here is where it's equal, it defines the situations where this is equal to 0. Remember, the unit for force is newtons. And the first case over here is when it is stationary or at rest. Those two things mean the same. So if you read in a question something is at rest or stationary, you immediately know that the net force is 0. And the second case that we have over there is when something is moving at a constant velocity. Okay, so a constant velocity. So let us look at an example of where we'd apply this, or how we'd do a question where you'd use this kind of information. Okay? So let us say your question says, the box is moving at a constant velocity . Complete the free body, okay. Okay, so we're going to have a free body diagram here. This box, so this is a free body diagram of the box. Say they give us that it's being pulled by the tension force, which is 20 newtons, and that the gravitational force. Okay, and remember, whenever you are on Earth, and very few questions are set on a place that is not Earth, or even on the moon, you're always going to experience this gravitational force, right? And the gravitational force is m times g, but in this case, they just gave it to us as 30 newtons. Okay. Another notation for Fg, if they use it in your textbook, it's fine, is W, the weight, the equivalent. So whether you label it W or you label it Fg, it's the same thing. So let's say they gave us this situation and we had to complete the remaining forces over here. So what they've given us is there's a tension in the rope of 20 newtons, and there's a gravitational force of 30 newtons. Now, they've told us over here very clearly, well, the question has been set in such a way that it is in constant velocity. It's moving at a constant velocity. So, from what we know from that is that the F net is 0 newtons. Okay, so that means that the sum of the forces on the same plane is 0 newtons. Now, if the tension is 20 newtons to the right over here, that means there is some opposing force that's equal but in the opposite direction, because this is going to have a minus sign. So let's call it the frictional force. So the frictional force is 20 newtons because that opposes motion. Just make sure when you're drawing your free body diagram, if they have the same magnitude, they're the same length. Now, mine is slightly different, but you should have it in your diagrams. If it is the same magnitude, then it's the same length. Okay? Now, that's in that plane, we can see the forces cancel out. But what about in our vertical plane over here? Well, if there's a gravitational force of 30 newtons, and if the box is on a surface, there will definitely be a normal force. Okay, and the normal force is a force that's perpendicular to a surface, and if the downward forces from the gravitational is 30 newtons, that means that the upward forces must also be 30 newtons. This is a system that's in equilibrium, constant velocity, so the net force is 0, so that means the forces all cancel out. So when you're drawing a free body diagram, you make sure that the lengths of the vectors are the same. Okay, because if you draw one bigger than the other, then you're saying that that force is bigger than the other, and it's not, because the F net must be equal to 0 newtons. Okay, let's do another example. So let's just say we've got this guy on a parachute. Okay, my drawing skills are not excellent, but he's moving down at a constant velocity. So we have that he is moving so they've said that, and also all together they weigh, so him and his parachute have a mass of 65 kilograms. Okay, and let's say we have to draw the free body diagram. So that's just free body diagram. I'm not going to write the whole word out. Okay, so let's start. Okay, so there aren't any forces moving it left or right, because he's only moving downwards, so there's no forces in that plane. So I'm not going to draw anything on the horizontal plane. Okay, so what forces are acting on him? Well, he's moving downwards. What is causing that downwards movement? Well, he's on Earth, so it can only be the gravitational force. Okay, and the gravitational force is M times G, and in this case it is 65 times 9.8. Okay, you guys can go calculate that, and the unit is newtons. Okay, so that is the gravitational force. Actually, let me just tell you what 65 times 9.8 is. It's 637. Okay, so the gravitational force is 637 newtons. He's moving downwards at a constant velocity. So again, we have this constant velocity, and by Newton's first law, what do we know? That the F net is equal to 0 newtons. So if there's a downward force of 637 newtons, that means there must be also an upward force of 637 newtons. What do you think this upward force would be due to? Okay, so in this case, it is not a normal force. How do we know it's definitely not a normal force? Because in order for it to be a normal force, there must be a surface. Is the skydiver anywhere near a surface? No, he's in the middle of the air. So something that could have caused the 637 newtons upwards is something like air friction. Okay, so that is an example of another example of Newton's first law, well, the applications of it. I hope you understand, but just to recap, Newton's first law. So his first law identifies the cases where the net force is 0. Okay, and if you read these words in your question paper or in the test, you know the net force is 0, and it's either if it is stationary, okay, and stationary is the same as being in rest, or if it is moving at a constant velocity. Okay, so these two identify the cases where the net force is equal to 0. Okay, so please remember how to do these types of questions. The next video maybe we'll have something a little bit more complicated, but that's it for now. Thank you for watching. Please send your comments in the comment section below to tell me what would you like to watch, what questions do you find you have problems with, how can I improve my videos, and whether you've enjoyed it in general. Please tell your fellow grade 11s to subscribe to this channel. I plan on posting a lot of things on maths and science. Please, thank you. Have a good day.